All right, part 2, lesson 4.3. Again, we're still writing linear equations in point-slope form, but here we have a couple challenges. So first, it says find the value of k so that the line passing through the given points has slope m. Then they want us to write an equation of the line in point-slope form. So recall that point-slope form is y minus y1 equals m the slope times the quantity x minus x1. And the x1 y1 are points that were given, or a coordinate that were given. So here this looks kind of funky with all these k's. I know that my slope is -1, so I'm going to go -1 equals, and I'm just going to go ahead and write the equation. I have 4k minus 3k over k subtract, and I'm going to put this in a quantity, k plus 2. This is the biggest mistake people make. If they don't put it in a quantity, they notice, oh, k minus k, but then they still want to go plus 2. And you're going to see that that's not what we do. So I'll simplify with my k's. 4k minus 3k is just k. K, here I have to distribute the negative. So k minus k, they do cancel, but -1 times 2 is really -2. So now I can multiply both sides by the -2, and I see that +2 is what the k equals. Now that I know k, I can figure out this point and this point. So the first point is k, which is 2, and 4 times k, so 8. My second point is k plus 2, so 4, and 3k, or 6. Now I can go ahead and write my equation in point-slope form. I've got two choices. You only have to write one, but I'm going to go ahead and write both of them since I'm showing you the example. So if I use this first point, I'll go y minus 8 equals m, which is -1. You can put the -1 in, or you can be fancy like the book and just put the negative sign, and then x minus 2. Or if I use the second point, it'll be y minus 6 equals, I'll be fancy like the book, negative, and then x minus 4. So either of these are okay. Excuse me. Oh, here we go. Goody goody. Story problem. Bryce Canyon National Park from 1990 to 2000, so year 0 to year 10. The number of visits by people to Bryce Canyon National Park increased by about 23.9 thousand visits per year. It increased by this per year. Hint, 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 that's our rate of change, that's our slope. In 2000, year 10, there were 1,102.4 thousand visits to the park, so that can give me a point. So my slope is 23.9, I know it's in thousands, and my point is in the year 2000, which is year 10, we had 1,102.4 thousand, so there's my point. Write an equation that gives the number of visits in thousands as a function of the number of years since 1990. When they say as a function of, that's code for saying slope-intercept form. So as a function of does not mean point slope, it means slope-intercept form. You can do it one of two ways. You can either put it in point slope form first, and that's the way that I'm going to do it because I want you to see how we do this, or you can just say, well, there's my x, there's my y, there's my slope. I'll substitute it in, find my y-intercept, and be good to go. So your preference, but I'm going to show you point slope form. So I have y minus 1,102.4 equals m, 23.9 times the quantity x minus 10. Now I referred to this yesterday, and I said you could go ahead and solve this for y, and that's what we're going to actually do. So to do that, I will go ahead and distribute the 23.9. So I have y minus 1,102.4 equals 23.9x minus 239 when I distribute. And now I'm just going to add the 1,102.4 to both sides. So I'll take my negative 239 and I will add 1,102.4. And yes, I am using a calculator for this. So I end up with y equals 23.9x plus 863.4. So there is my equation. There's part A. Part B, how many visits were made to the park in 1995? Well, 1995 is year 5. So I will just substitute y equals 23.9 times 5 plus 863.4. So 23.9 times 5 plus 863.4 gives me y equals 982.9, but it's thousands. 1,000. Or if I just multiplied that by 1,000, it's 982,900 people. Because really, who talks like that? 982.9 thousand. It makes more sense, 982,900 people. And that seems legit for, you know, that many people to visit a national park. All right, airmail rates. The table shows the cost of mailing different weights of airmail letters to Canada in 2005. So these were all in the same year. Explain first of all why the situation can be modeled using a linear equation. Well, we have to understand that the slope is going to be the same no matter what 2 points that we use. So from 2 to 3 to 4, I can see that my change here is 1, and we'll discuss the 8 in a minute. From 85 cents to $1.10, that's a change of a quarter. From $1.10 to $1.35, that's another change of a quarter. Here, this is a change of 4 and a change of $1. Well, $1 divided by 4 does still give me a change of a quarter. So why can it be modeled using a linear equation? Because weight is increasing at a constant rate, and so is cost. Now they want us to write an equation that gives the cost in dollars as a function. Remember, that's code for slope-intercept form. So basically, I really just found the slope. It was the change in y over the change in x, so it's a quarter. So my slope is a quarter. And I can use any of these points if I want. So I like to use the first point. I'll use 2 and then 85 cents. Again, you can go ahead and do it with slope-intercept form right away, or you can put it in point-slope form. Since the other one I did in point-slope form, this one I will put back in slope-intercept form. So the y is 0.85, remember slope-intercept form, equals m, a quarter, times x plus b. So 0.85 equals, well, 2 quarters is 50 cents plus b. And if I subtract 50 cents from 85 cents, I get 35 cents. So my equation is y equals 0.25x plus 0.35. How much does it cost to mail a 5-ounce airmail? So x equals 5. And I just plug it in. Y equals a quarter times 5 plus 35 cents. So 5 quarters is going to give me $1.25 plus 35 cents. Altogether it's going to cost $1.60 if I want to mail one that's 5 ounces. Alright, let's see what I have up here next. Oh, I don't have anything, so it's time for the lesson. This will be lesson 4.3 part 2. Page 245 to 248. Problems 32 to 36 even. 37 to 40. And 42.